This class we will see the continuation of previous one. That is, in the previous session we saw about the introduction to diathermy, and the continuation of that will be the diathermy electrodes and coagulation. So in this class we will see something more about the term called as coagulation. Okay, so let me present it now. Next, this one is nothing but the electrode types. Okay, so basically you have two types of electrodes. One is monopolar and another is bipolar. Actually, which is not included in this side. This presentation is actually we don't have this presentation is not in depth, so this is not within the scope of this presentation. So that is not included here. Anyway, to have an idea about coagulation, you should know about the electrodes and its function. So that is what this is included, that is why it has been included here. Okay, we will see that as I told you that you have two electrodes. One is monopolar and then bipolar. But anyhow, to give an idea about what is monopolar, you'll be having only one electrode, which means that you'll be having one main electrode, another is the reference electrode, which we saw it in the previous session also. So there was a surgical unit, which in that there was a diagram which is shown. Doctor was doing a surgery. In that we saw the picture. In that and the bed over which the patient is laying, you will be having electrode that is called as a reference electrode. And that type of thing is called as monopolar electrodes. And then next is bipolar. So bipolar means here that, excuse me, so in bipolar you have two electrodes. So both electrodes will be present side by side. So you don't have a fixed electrode as a reference electrode. You will be having both the electrodes to be taking place side by side, which will be present available side by side. Okay. So in this case, you have the spark. Okay, so if you take the spark here, you have different types. There is no spark here, and then this is a cut spark, and this is a coagulation spark. What is mean by cut spark? The cut spark means that in diathermy, if you want to cut or if you want to bisect, you have to use a spark, which means that the heat, it is nothing but heat. Okay. But to give you an example, to have an understanding or example, with an example you'll be able to understand much clearly. So the example will be this one. So during Deepavali times, you may be using crackers. Okay, you may be burning crackers. So if you take flower pot, in that you'll be having the sparkling to be in different way. From it comes like a fountain. Okay, it comes from a, it seems to be like a fountain which will be spreading across and it will be falling down. That is one way of visualizing your spark. And then next is, if you take the pencil like items or some other what is it, sparklers. So in that, if you take the sparkles will be coming out in a different way. Anyway, it will be like a flower shower. But there is a difference between the shower which is coming from a flower pot, from a the other things like pencil or something like that. Okay, these are some of the sparklers, color sparklers. You have a lot of Deepavali things. Okay, so firecrackers in that. So you can, I think you may be able to understand what I'm trying to say. So in that way, in the same way, you know that it will be only heat. Spark doesn't mean that it is going to be the real spark that you are as you imagining. This is just, spark means that here we are meaning only the heat waves which will be coming out in the form of a spark. That's it. That's the idea. Okay, the dotted line represents the spark. That's all. So if the spark is in this type of direction, in this way, in this method, then that particular spark can be used to cut the tissues. That is the idea behind it. If you use this type of spark, which will be having spreading, okay, you can see here the dotted lines are spreaded over this particular area. So which means that this is used to coagulation. So what is mean by coagulation? So coagulation is nothing but you know that if someone gets poisons, okay, if someone get poisoned, what they will do is that to kill that poison, they will give another poison. In the same way, this method, using the same heat treatment method, you can join the tissues, you can seal the tissues, you can without stitches you can uh, combine the tissues, you can make it as a normal skin. That is called coagulation. Okay, so in coagulation the heat can be used, and the same way the diathermy also the heat can be used. In both the ways the heat will be used. So if the spark that is coming out of the machine, that is electrical surgical unit, is in this way, then we call it as a spark which is used to cut. Okay, if the spark is in a flower like structure, then that will be classified as coagulation sparking, which means that it is used to heal the cut tissues, or it which is used to combine, which is used to link, or which is used to join the tissues. Okay, so using the same heat you can join, and using the same heat you can cut it into two different halves. Okay, so that is about this slide. Next slide is about this electrodes, the type of electrodes. So this you can see that it's in a spherical shape. So this type of electrodes, it is used for coagulation, which is not used for diathermy, which means that to cut you will not use this type of electrodes. So as I told you that you have majorly two different classification of electrode. One is monopolar and then bipolar. This is the example of monopolar, which means that you have the electrodes here, and the reference electrode or the written electrode is placed here. Over that you have the tissues or skin or a body or a patient will be there, and over that you will be having at a distance away. Okay, this is actually a distance. This is electrode, and this is the patient surface of a patient's body. It may be a finger, it may be a skin or a skin surface, or it may be a face surface, or it may be a stomach surface, or it may be a leg surface, it may be anything. Okay, this is the surface of a body. Okay, over that the electrodes will be held at a particular position. It won't be kept close to the skin or over the skin. It will be just placed slightly away from the skin. Okay, so that the heat can be transferred, and that can be used to effectively to cut or to combine the tissues, or to intercept the tissues. So this is one way. Okay, the other way is bipolar, and that as I told you, you can see here, this is one way, one electrode through which the heat wave will be generated, and it will be sent here, and this will be completed by a return path which will be available adjacent to the this type of electrode. Okay, so this is called as a bipolar, and here this type of things are used to bisect, or to mainly you will be using only to bisect the skins. Okay, to tear the skins we will be using this. So this type of thing, this we name it as a hemostat, the hemostat which is used to lift the tissue. You can use it to lift the tissue, which means that to lift the skin. Okay, to lift the skin you have to use this. To do the cut like structure cutting of a tissue, you can use this one. To cure the tissues or to bind the tissues, then you have to use this one. So these are the different type of electrodes that you have in diathermy or coagulation. Okay, next one is the block diagram of coagulation. So here you can see the patient is lying on a bed, and here you can see the reference electrode, and this is the source of heat energy, and which is controlled through this power amplifier. The power amplifier can be connected either to this one or either to this one. Okay, if you connect this one, this will operate as an, if the power amplifier is connected in this mode, then this will act as a coagulation unit. Okay, so if the switch is moved to this one, this will act as a diathermy. This power amplifier will act as a diathermy. So this is the idea behind the block diagram. Okay, so the same circuit can be used for two different purposes. One is to cure and another one is to cut, which means that either it can be used to, technically speaking, either it can be used to cut or bisect, and to combine the tissues or to join the tissues. We can use this. Okay, so if you as you can see in the block diagram, this is the source of heat which is generated through the RF oscillator, and this is the power amplifier where you have the electrodes to be connected, which is used to send the heat. And this power amplifier is controlled by a switch, and either if the switch is connected to this oscillator, this will be used as a what to say that this will be used as a diathermy, and if the switch is connected to this unit, then you call it as a coagulation. Okay, so the coagulation here is done using mux. This is a mux, this is not a multiplier. Sorry for mentioning that. This is wrong. This is actually a mux. Okay, so this means that multiplexer. It is not a multiplier. Mux. Okay. multiplexer. So either you can use it as in the coagulation mode, or further you have another 3 switches. Either you can use it as in coagulation mode, or you can use it in a blend mode, or you can use it in the blend mode. You have two different options. One is blend 1 and another is a blend 2 option. This you have lot of options in this blend mode. Okay, so this is the idea behind the block diagram of coagulation and diathermy. Combined together you have this diagram. Okay, next you have the timing diagram. So timing diagram, in the previous slide you can see that this is coagulation and this is diathermy. So if you see the timing diagram, you can see that, as I told you, that we are using only the uh, high voltage. Okay, so this diagram helps to realize the voltage, to have an idea about the voltage that is used. Okay, if you want to use it in the coagulation, not coagulation, to cut, or diathermy, if you want to use it as to in a diathermical stage, or if you want to cut the tissues, then you have to use this much of energy. Continuously it goes on. Okay, that you can see the diagram, it continuously goes on, and that is called your diathermy. And then next you have coagulation. This diagram, where you can see that instead of generating a continuous heat, you have a warming period or a cooling period. So that is why you don't have the signals here. That is given as a straight line here, which is in a horizontal way, not in a vertical way. So this is the maximum peak and this is the lower peak, and which is continuously occurring. Then it is called as a cutting. And if some portions of the continuous waveforms are not available, then we name it as a coagulation, which is called a cooling period, which is not continuously generating heat. Okay, so that we name it as coagulation. And there are other two options also. The one is blending 1 and then blending 2. When you see that this one, here we have more cooling period when compared to coagulation. So it's more or less like a coagulation only. Okay, so in coagulation you have 3 different ranges. One will be this one, another will be this one. Instead of calling it as a coagulation, we will be calling it as a blending 1 and blending 2. The difference between coagulation and blending is that you have a lot of cooling period over this and this one. So the purpose of this is to have a precise joining or binding of tissues. Okay, it also depends upon the place in which you are going to combine the tissues. It may be the skin that is available over a elbow, or it can be over the skin that is available across a toes or something like that. Okay, so that is what is given here. But before that, I forgot to say, I mentioned one particular key point, that is coagulation. I gave you an idea. Okay, I think you may be able to understand what is coagulation, but how it is taking place, that is very important. So how it is taking place, coagulation. So if you are going to place the electrode, if you are going to place the electrode over the skin surface, due to heat, what will happen is that the liquid particles which is available in the tissue will be evaporated, and that way what happens is that the tissues will become closer to each other and automatically gets binded to each other. Okay, but it is possible only if you keep the electrode away from the skin. Okay, if you're going to keep the electrode over the skin or over the tissue, then definitely it will have the cutting edge. Okay, it cannot be used as a coagulation, it will be used only as a diather. Okay, so that is this one, that is the idea behind the coagulation. And next, this is the last slide, and with that we'll be completing this topic. And this table gives an idea about the amount of power that is consumed by each and every mode, and the duty cycle that is taken by each and every mode. If you want to use it as a coagulation mode, or if you want to cut something that is tissues, then the amount of power that is used is 400 and the duty cycle required is 100. In coagulation, the power utilization is less, and then the duty cycle is also less. If you want to have more or faster coagulation, then we go with blend 1 mode, and still if you want to have it more faster, then you have to go for blend 2 mode, where you can see the amount of duty cycle and then the power consumed by each and every mode. With that, we are completing this topic, and thanks you for all, and we'll see in the next class. Thank you.